has coordinated 6 HTTP, including Atal FDP at Bharuch. He has delivered more than 25 national and international level expert talks at various reputed universities across India. He has research opportunity with scholarship and visited Technical University of Munich, Germany in March-April 2019. He has also served as a technical program committee member in conference organized at Scientific Federation of Dallas, USA and Morocco. He has served as a track chair for IEEE IES in 2021 at Kerala. He also chaired a technical sessions in IEEE sponsored international conference at IIT DM Kanchipuram, Chennai. He has organized a special session in most reputed IEEE ECCE 2020 conference at USA. He has also organized a session in ICCE Asia 2021 at Singapore. He is also serving as a potential reviewer in various reputed journals such as IEEE Transaction of Power Electronics, IEEE Transaction on Industrial Electronics, IET Values, etc. He has nominated Best Researcher of Year 2019 in Electrical Department SVNIT Surat in 2019. He has also serving as an honorary advisor in GMDT Marine and Industrial Engineering Private Limited, Ahmedabad. He is also serving as an honorary advisor in Cubetic Industries Private Limited, Surat, India. He is a life member of Indian Society of Technical Education, and recently he was included in advisory board as a member in Secretary of Power Engineering, Vadodara chapter. Now, without wasting a time, I request Dr. Asutosh sir to start the session.
Thank you very much, Professor Nikunj, for such a nice introduction to the participants. I am very much thankful to you for organizing this session. And now I would like to share my slides. Still, I am looking, attendance is very poor, but after so many requests, participants are not listening. Let me share my PPTs. Is it visible?
Yes, sir, it is visible.
Yes, sir.
Okay, nice. Now we are entering in the third day of the FDP. Fortunately, I had an opportunity to take this session, and very first lecture I am going to deliver of this FDP of day 3. Basically, the aim of this FDP is to acquaint the concepts of power electronics, power system, power quality, reliability issues. That means I tried my level best to accommodate something for the power system people and some other things or some application of power electronics control system in the power system for maintaining power quality of the system, for maintaining reliability of the system. In the previous FDP when I conducted, most of the contents were related to power electronics people. That's why in the feedback I observed that people were demanding some concepts, something new, some happenings in the power system also. That's why in this FDP, some sessions are based on power system reliability, some sessions are based on power system quality. Now today's session basically it is more or less power electronics application in power system. Now we all know, being an electrical engineer, basically there are two kind of systems in existence. One is conventional system, what we know, that is interconnected system, and the second is, and nowadays gaining much momentum, even since last 5 years, a lot of work is going on based on distributed power generation and microgrid, and particularly renewable energy based distributed generation. So basically, we will discuss here in this session what is basically distributed generation, how we can optimize, how we can maintain the power quality of the distributed generation. I think so. Someone's mic is on. Mm, please make sure you are muted. Please make sure your camera and your audio both are not available. Please just listen, and if you have any query, then you ask, please. Otherwise, it will be a disturbance. Now, what we were discussing, we will discuss here some concepts, some applications of power electronics. Let me my camera also turn off. It is not required. Now we will discuss here some concepts of power electronics application in power system, basically to maintain the power quality. Power quality is very general term actually. Power quality means what? What do you understand by power quality? This is my one simple question to all of you. Can you tell what is the power quality? It is very common terminology actually. There is nothing new in the terminology of power quality. Just I would like to make the session very interactive. It is not, it should be, that means basically in my session, basically what we are doing, we are focusing much on distributed power generation, right? In the conventional power system, one part of the system is totally passive, and you know there are three parts of the system. In conventional power system, generation, transmission, distribution, and utilization. So basically, utilization level, that means the end customers are very passive in nature in the conventional power system. Whether power factor is poor, whether they are not getting the pure sinusoidal waveform, whether they are, that means they are maintaining their zero reactive flow into the devices, or that means they are least concerned with all these quantities. Just what they bothered, their work must be going on, their fans must be running, whether it is consuming much reactive power or consuming less reactive power, whether power factor maintained at their end or not. Because actually in India, electricity bill is also not charged like at industry level, it is charged according to the kVr power factor. That means they are compelling you to maintain the power factor. But at the domestic level, it is not like though. Though your power factor is poor, still you are charging on the basis of kilowatt hour only. Right? That's why one end of the power system in conventional is passive in nature. Right? But in distributed power generation, that is the beauty of distributed power generation. Anybody can participate in the generation. It is not like only generators at the larger power stations are only contributing for the power generation. Any stakeholder of the power system, consumers are also one stakeholder. Any stakeholder of the power system can generate their power, can supply their power, can claim their rebate. Right. So this is the beauty of.
Hello, sir. Your PPT is not visible.
Uh, yes, this is the beauty of power system, distributed power generation system, where all are active. So similarly, in this session, you must show some activeness from your side so that every stakeholder of this FDP become an active member. Now, basically, as far as this topic is concerned, we will discuss here the role of intelligent controllers in distributed energy sources. Basically, there are two things in the distributed energy sources. Either sources are connected from the grid or sources are running in standalone mode like solar rooftop system, a wind rooftop system, or combination of solar wind rooftop system. So these are they may be in standalone mode, they may be interconnected to the grid. So these things we will discuss. Now the problem of the distributed power generation is what? What is the problem of the distributed generation? Can anybody guess? Can anybody assist me? What is the problem in the distributed power generation? Are you listening me?
The multidirectional power flow.
Yes, very nice point. One point is multi-directional power flow. That means in the radial system of the conventional in nature, you have seen power is flowing from only generator side to load side. But in the distributed energy system, because most of the distributed energy sources are generating their power at low voltage level. We all know they are not generating in kilovolt. Suppose solar rooftop system that is generating power at 220 volt for 400 maximum 400, right? So what you are doing, you are generating power at low voltage level, and then you are by some interface power electronics devices, interfacing power electronics devices like solar inverters and all, you are changing the voltage level by boosting the voltage level. DC-DC converters are used for boost up, and finally you are connecting from the grid. And suppose if you are not connected from the grid, if your system is running at a standalone mode, you are generating power locally and you are distributing it locally. So basically the main application of the distributed energy sources are to feed the power at the remote locations. Basically, where grids are not available or grid supply lines are available, but they are very costly. Energy efficiency is one point, because when transmission, distribution, everything is related in power system. If everything is associated in the power system, definitely there will be a just T&D losses and energy efficiency will be going down. But most of the distributed energy sources, those are running under standalone mode operation, they are highly energy efficient, right? So there was that means one challenge, how to control the power flow, how to inject power with zero reactive injection, right? So these are the problems, these are the challenges associated with distributed energy sources. There are one more challenge. There are another challenge. I want to listen from the participants again, because the first point was suggested by a very nice point was suggested by some participant. Now again you can participate in this discussion. What are the other challenges of the distributed energy sources? One is bidirectional power flow and its control. Second is, anybody else?
Good morning, sir.
Yes.
We cannot able to predict the power of this DER, sir, because solar and wind we cannot able to predict the amount of the power which is been there.
Yeah, that what I understand from your word, that means you want to say these input sources are intermittent in nature, right?
Yes, sir.
Sometimes wind will be available, sometimes solar will be available, sometimes wind, solar both will not be available, sometimes both are available. There are some permutations and combinations, right? If you are working on the hybrid system, you have to take all those permutations and combinations. And if you are working on only one device, that means one energy source system, like if you are working only on solar, if you are working only on wind energy system, then you have to plan and make your system according to the availability of the wind, according to the availability of the solar irradiation, right? But definitely your point is clear. Both sources are not predictable. That means you cannot predict tomorrow there will be the wind velocity of 10 meter per second, or today in the evening there will be 13 meter per second. There may be predictions, but always it may not be right. That's why unpredictable nature or unpredictable behavior is another challenge, because we know in wind energy generation, generators are connected from the windmills, and if windmills are changing its speed, windmills are getting different energy at different time, because fluctuation nature of the wind will not supply continuous power or constant power to the windmill. That may supply some variable amount of power. That means generator will generate. Ultimately, generator is not doing anything. It is converting mechanical energy into electrical energy. Then ultimately generator will also generate variable power. Though you can tap maximum energy from the available wind speed by using MPPT techniques, but it will be variable. At each and every time you will not get the same peak of the power, right? So to maintain the supply from the generator towards load side at constant frequency and at constant voltage is one another challenge. So basically in distributed power generation system, now the tone is set, we can move forward with these challenges, right? Now how to control the power, how to support generator for maintaining the frequency, or in solar system how you maintain the power, constant power supply to the load. So all these things will be addressed in this session, and we will discuss how controllers may be effective for supplying, for maintaining voltage and frequency in the variable loading conditions, in the variable input conditions, because here we will consider both conditions, variable load, because load is also unpredictable. Nobody can predict about the loading conditions, right? You can have some guess, yes, at this time peak will come, or at this time, at this moment, this much watt will be demanded, but exact prediction is not possible for loading as well as for input side. Input side means, I mean, the variation in the solar irradiation and variation in the wind velocity. So these things will be considered in this session. That means we will study entire distributed power generation. Having sometime we will take only wind energy system, sometimes we will take solar and wind in combination, and we will discuss, we will simulate our system, we will discuss how to maintain the voltage and frequency, how to maintain the power quality, how to maintain the sinusoidal supply from the generator end, right, despite the non-linearity in the load. So these things we will discuss one by one. So I think so the objective of the session is very much clear, and we will discuss the things in this manner. First of all, distributed energy, what is distributed energy generation, then various architectures, configurations, and we'll discuss some research scope as well, control algorithms, and then intelligent control algorithms, and some adaptive control algorithm applications I will discuss here, and how to apply basically intelligent adaptive Adaline control algorithm. All these things, some simulation results and DG prototype hardware development and experimental results I will discuss in my second session, but my target is to come to up to the simulation results. Now, basically, the distributed energy generation, as I was discussing in the starting of the session, there is one component which is missing in the distributed energy generation if it is working in the standalone mode. My point is very much clear. Distributed energy generation may be standalone operation and may be working in the interconnected mode. That means they may be connected from the grid also. But here my focus is to discuss distributed energy generation in the standalone mode, or we are making one system, we are planning one system to supply the power at remote locations or where grid is not available, and we will maintain the power quality as per IEEE standard, so that the connects that means the population which is connected from such kind of systems they do not suffer with poor power quality, right? Because poor power quality will create a lot of things, a lot of side effects I will discuss in the later slides. So basically, distributed generation is one that means distributed energy. We can say on-site generation, district decentralized energy is electrical generation, and storage performed by a variety of small grid connected or distribution system connected devices referred to as distributed energy resources. Basically, distributed energy resources are always interfaced with the power electronics. The power electronics interface is needed in such kind of devices. If you are taking without any power electronics, such kind of devices will not be as much reliable as they should be. DG addresses concern about stability and power quality as well, with self-sustainability and fault tolerance, right? This should be the characteristic of the distributed generation. However, there are some issues and challenges regarding effective power system operation and control. As somebody was discussing, like a bidirectional flow is possible. Suppose if you are connecting your generator from the grid, then the possibility of the reverse power flow is always there, right? You have to control the reverse power flow by installing some protection devices or by installing some specifically power flow control devices, right? So that, but if this system is working in the standalone mode, there is no question of reverse power flow, because your generator is less inertial source, and your load is only consuming the power. There is no generation from the other end. That's why that possibility is not, that is the flexibility of the standalone distributed energy generation. And the interconnection of a large number of renewable energy sources to the grid causes the problem of control and stability. Yes, because we know grid is having some own problem. Grid is a very inertial system. You cannot, that means easily voltage and frequency cannot be changed in normal grid conditions, right? And control, because due to a large number of lines, generators, transformers, there are so many elements in the interconnected grid, and controlling at every part of the system is not an easy task, right? That's why distributed energy sources in standalone mode is more preferred if it is that means the aim is to supply power at the isolated locations. Now the suitability of the distributed generation, as I discussed earlier, feeding power to remote locations. The system is very easy to control and operate. The reason is it is not having so many components. Suppose if you are installing your solar rooftop, only one component inverter, and then solar panels will be involved, and you can easily just design one controller for the inverter operation, and easily it will be controllable. You can control the power flow, you can control the things, right? For increasing the renewable energy share, because nowadays a lot of discussions are going on global warming, on climate changing conditions, right? So these things are very much important to switch over to the renewable energy, because nowadays conventional system share is still very high. Coal burning share is still very high. That's why we have to reduce the carbon emissions by increasing the renewable energy share, and this is possible only when we are going for the distributed generation. No need of regulatory bodies. Suppose grid code will not be applicable if you are running your system in standalone mode. This code will be very much important, or it will be applicable on when you want to connect your system from the existing grid, right? But if you want to run your system for your own purpose, then regulatory bodies are not required. Less expensive, one time investment is there actually, otherwise you will get the payback. For reducing the burden on the grid, grid modernization and reduction of the burden on the grid, there are two criteria, because we have to give some time to the grid for modernization and for making it smart, right? So that it can be used much more effectively. That's why renewable energy share must be increased in terms of distributed power generation for reducing the greenhouse emission, for increasing the overall economy, for better living standards. People are living at isolated places without electricity. In world, there are so many locations in South African countries where people are still not having grid connectivity. So it is better option for them actually. In India, some lakhs of people are there, still they are not getting any kind of supply, or grid connectivity is not there. And if that grid connectivity is there, that becomes very impractical solution, because if we consider the hilly regions where maintenance is very difficult, power erection of the transmission line is very difficult. That's why these kind of generations are always encouraged to supply the power at those locations. Increase the energy efficiency, it is very important term, and effectiveness of the power system. If energy efficiency is there, then it is very nice, and ultimately that rebate can be transferred to the customer end. And if we are making a lot of losses, again that is not good for the system. Peak load reduction is another one thing, because if you are demanding same much power at the same time, that means we have to increase the installed capacity of the system, and that will need some capital investment. Again, money involvement will be there. That's why by taking the distributed power generation in consideration, you can reduce the peak load. Enabling the grid modernization, as I told, if we are reducing the burden on the grid, some lines, some part of the system can be modernized, some part of the power system can be some amount of power can be diverted from other routes, and some section of the power system can be relaxed for some time, and you can modernize the grid, you can install the smart devices, you can enhance the efficiency of the system, like this. Encourage the third party investor. Actually, a lot of investment is happening in the zone of distributed energy sources, like you can see the solar park. Adani is investing a lot of money. Even that means Reliance Energy is also investing a lot of money in the solar park zones. They are creating their own solar parks. They are in megawatts, not in kilowatt. Or that means they are generating. Suppose Adani is the highest solar energy generator in India, right? They are generating in 4,000, 5,000 megawatt, and they are building their own solar parks. The local control for maintaining power quality and reliability. This is happening. This is possible only when your system is running in standalone mode, right? Your generation is in isolated manner by using either solar or wind or combination of both. The promotion of community involvement in power generation, all these things are very much important when we are going towards the renewable energy generation mode in distributed generation. Now, what are the basic challenges to develop the DG? The selection of suitable site is one more. That means first challenge is you have to select the site. Suppose some sites are very much suitable for solar power generation, some sites are very much suitable for wind power generation, and some sites are very much suitable for both. That means hybrid power plants can be installed at some suitable sites. Hybrid power, actually in India, there are 4 5 major hybrid power generations of combination of solar and wind. One is in Kutch, Gujarat. Another is in Tamil Nadu. These solar power and hybrid, that means wind power, they are taken in combination. But solar parks and separate both. If that means the separate system like solar and wind separately, there are so many sites. You can go on the map of the India and you can see. And if you travel towards the Maharashtra region from Jalgaon to Surat, you will see a lot of windmills are running in parallel, right? And solar parks are also installed at so many sites where intensity. Suppose Rajasthan is one very nice place to install the solar park, where most of the sun intensity is most of the time sun is there and intensity is quite high. The selection of generator resources such as solar or wind or biomass, tidal or ocean-based DG actually that means you have to select which source uh, is much efficient at the various places. Suppose solar, at which place this will be generating more power, wind or biomass. Suppose biomass is one thing, or tidal. You cannot get any everywhere. You have to do some survey. That means these sources are somewhat typical energy sources. We have to do a lot of survey, and then we can get some energy reserves for the biomass. Similarly, in the tidal where waves are very much energetic, they can you can install the tidal or ocean based distributed generation. And basically in this segment, solar is the only DC source power generation actually. Otherwise, wind, biomass, tidal are all these sources are based on generators. Generators are the dynamic components, or you can say inertial components. Solar is not having any kind of inertia. It is creating power in the DC form, and through the DC-DC bidirectional converter or buck boost converter, you can enhance the voltage level, and directly with the help of inverter, you can convert into AC. Frequency will come at the end of the conversion, but here in these devices, like in wind energy generation, in biomass generation, in tidal, ocean wave, inertial component is involved. That means frequency will be there, voltage will be there, right? And voltage, most of the time you will get the voltage in the AC form. That means direct generated voltage will be in the form of AC. You have to convert using converters, AC DC converters for making it DC. And to maintain the voltage and frequency is a big challenge in the distributed generation. Continuity and reliability is another big challenge. That means power is not continuous in nature, right? Generated power, sometimes it will generate more, sometimes it will generate even less than the load demand. Then you must have, if your system is working in the standalone mode, some kind of energy storage is must. Otherwise, it will be difficult to maintain the continuous load supply to the in the system, right? That's why if it is grid connected, battery may be there, battery may not be there. But if it is a standalone generation, you must have to connect the battery component, which will be helpful to maintain the power supply, because it will provide some power backup, right? And then cost constraint is also there. Regular maintenance is involved, because as in the previous in the morning, yesterday in the morning, Professor Masudan was talking about the maintenance problem, and he was talking about the wind generation, and towers are so high, 140 meters, and it is not easy to maintain the operation of the generator at such a height, because generator is installed across the wind turbines, right? And all these lack of experience with DG and tariff structures, all these are the challenges in DG development. Now this is the renewable energy scenario, and this is provided in the MNRE website, and you can see there still we are generating most of the power in Indian scenario from the coal generation. This is the 54% most, that means 54% is shared by the coal power generation. Gas power generation 6.9%, nuclear is very less. Actually, it should be quite high, but still we are very much lagging due to dependency on some other countries. Easily uranium is not available in India. That's why the share of this nuclear power is very less in our country. Lignite based plant is quite less. Diesel, this should be less, and it is already very less power share. Renewable energy share is the our that means contention, bone of contention here, renewable energy. Renewable energy is only 30, near around 36%. And in this 36%, larger hydro share is also counted. If you remove this large hydro share, right, because this is basically large hydro power stations are connected from the conventional grid, they are not the part of the distributed power generation. That's why sometimes we can ignore it. But as far as clean energy is concerned, we can count the large hydro power generations as a cleaner form of the energy, right? But the situation of the wind power is very poor actually. Wind power is only contributing around 10%. Solar power is still less, but now the solar is going towards more contribution as compared to wind. But still solar power is lagging rather than wind generation. But during last 1 or 2 years, government has revised its target. Basically, before 2020, the target for wind was 100 gigawatt, and this solar power generation was 60, right? But now it is just changed. Solar power generation is going to be more than the wind power generation, because the things are very much clear why wind is somewhat lagging, due to requirement of the generators, due to requirement of the bulky turbines, due to requirement of maintenance. All these factors are contributing for less growth of the wind power. While solar power maintenance is quite easy, and life of the solar plates are, due to invention of new technologies, life is quite increased. Almost 25 years there is going, that means that is solar plates are going to exist for almost 25 years, minimum 25 years, nothing will happen to them. And that's why solar is increasing day by day. Biomass is still quite less. Actually, this segment should be given some attention to increase the generation from the biomass. Then small hydro is 1.3% only. And actually in European countries, this share is very high. If you go on any website of the European countries and you just see the renewable energy scenario, even smaller countries, they are contributing very high small hydro, because this is the power which is totally untapped in our country as well as in the Asian countries, because we are given very less attention for the check times. We have given very less attention for the tapping of the energy which is available across the canals, which is available across the smaller rivers, which are available across the some waterfalls. But in some developed countries, people have given much more attention for larger share of the small hydro, because that requires very less investment, and we can increase this share. In our country also there is a lot of potential available in the small hydro, but still it is going with some less space. Just allow me to take the attendance first, please. How many people? 90. Okay. Now what we were discussing. Yes, so this was the basically Indian renewable energy scenario, where we should give much focus towards all these four components: wind power, solar power, biomass, and small hydro. Even our government, central government, has set some target to increase the small hydro, biomass, solar, and wind. And I hope so within 2030, this reverse scenario we can see here. In this Indian scenario, we will see renewable energy share will be more than almost it will be 60 to 65%, and other power generations will be reduced. Otherwise, definitely we are going to face the climatic adverse climatic conditions. Now, basically, our focus in this session is going on power quality. What is power quality? Basically, if we talk about holistic view of the power quality, the term electric power quality is generally used to assess and to maintain the good quality of power at the level of generation, transmission, distribution. Basically, normal supply is always having sinusoidal waveform with the zero crossings at 0, pi, 2 pi, 3 pi, 4 pi like this. If sinusoidal wave is attaining its zero at the right place, attaining its peak at the right place, that means peak of the sinusoidal must be there at the pi by 2, 3 pi by 2, like 5 pi by 2. These are the places where sinusoidal peak must come. If this is the scenario and voltage and current, if they are not lagging much, if their zeros crossings are that means in the vicinity, then you can say yes, power quality is good. Yes, any query? Any question? Any query? Somebody was asking something. Okay, number of customers, equipment pollute the supply system. Actually, who are the responsible to pollute the supply? We people are responsible. We are using non-linear loads like battery chargers, like laptop chargers, mobile chargers, some that means television sets at day in. If you see the household devices nowadays, electronic based systems are increasing day by day. Rapid increment is there in the electronic based loads, right? Some adjustable speed driven motors. So these things are going to pollute our system, because actually power electronics is the main, you can say there are two things about the power electronics. Power electronics is the problem creating element in the power system first. The second important thing about the power electronics is at the same time it is providing the solutions also. That's why power electronics now integral part of the system, because power electronics, though it is creating problem for the power system, but at the same time it is providing the solution to the same problem, right? That's why nobody can ignore the role of nowadays power electronics in the power system, or power electronics in the that means for drive system also. These things are associated with the power electronics, and we are creating pollution by using excessive use of power electronics based devices, and we have to maintain, we have to provide the solution as well. So basically there are two kind of power quality related problems. One problem is related to the voltage, and the voltage problems are like voltage harmonics, surge, spikes, notches, sag, dip, swell, unbalance, fluctuations, glitches, flickers, outages. These things are related to the voltage related power quality problems. And some power quality problems related to the current, like poor power factor, reactive power burden, harmonic currents, unbalanced currents, and an excessive neutral current in polyphase system. When we are talking about three-phase four-wire system, the fourth wire is neutral wire, and if load is not balanced, then the fourth wire will have zero sequence current, right? And that is going to make the system unbalanced. That is going to make system unbalanced. If reverse power flowing components are there, suppose negative sequence components are there, then again system is unbalanced, and that is the possibility in the three-phase three-wire system. In the three-phase four-wire system, the third possibility is to have zero sequence current as well. So these things are related to the power quality problems. That means in good power quality, there should not be any current in the neutral wire. There should not be any, that means measure lagging in the voltage and current waveform. Voltage and current waveform must be purely sinusoidal, and there should not be any voltage harmonics from the supply side. There should not be any surge or spikes in the voltages, notches. Ultimately, if these are available, these are present, in the waveform of the voltages, they are going to sometimes they are very much harmful to the loading conditions. If it is a critical load, suppose some ventilator is working with the supply system, and if you are not maintaining the voltage and frequency constant across the ventilator, then it may create some problems, because ventilators are working for some critical patients. So these things are very much important, and the importance of power quality nobody can deny. And these are the power quality terms and definitions, like transient, short durations, long durations, voltage variations, voltage imbalance, waveform distortions, voltage fluctuations, power frequency variations. All these are the basic terminology in the power quality terms, right? And you can see here it is like some transients, then some sag is available, is coming here for few cycles. This is swell for few cycles, interruption, and this is the notch coming at certain instants. Notch is coming due to short circuiting or due to short circuiting of the inductance, right? With the help of some waveforms, the same power quality problems are shown here. Like this is the, you can see here over and under voltages. That means this is suppose not normal voltage, and this is also not normal voltage, over voltage and under voltage. Then harmonics, due to harmonics, you can see here, you can see some settling points are appear across the current and voltage waveforms. Then flickers, you will not get the same intensity of the bulb. Unbalance, you will not get the equal magnitude across the phases. Sometimes two phases are equal, but third one is larger. And sags means this is the normal, suppose, then this is going to be a sag. And then swell, all these are the problems. Transients, interruptions, some cycles are missing from this supply. The frequency deviations, time cycle is not equal. That means here time is different. Here for these 2-3 cycles, time is totally different. So we can say these are the power quality related problems, and we have to provide some solutions for maintaining the supply system purely sinusoidal with good power quality. These are the power quality problems. And effect: poor power load power factor, harmonic contents in the load, notching in the load voltages, DC offset. DC offset is another problem in the power quality, and unbalancing, supply voltage distortion, voltage sag, and so on. And you can see here just why I kept this waveform here. Because if somebody is working closely in power electronics area, you must have some common understanding why suppose if this kind of waveform you are observing on the DSO, then you must know, without this knowledge you must know this is the presence of third harmonic. And if you are having two settling points over here in the top, then you must have the common understanding, like yes, third and fifth both are available, that's why two peaks are coming. And from where it is coming, actually it is just that means if you see one fundamental cycle, then if you see the third harmonic component, you will see 3 cycles within the fundamental. And if you see the fifth harmonic component, then there will be 5 times more cycle as compared to fundamental. And if you superimpose all these, if you superimpose 50 hertz, 150 hertz, and 250 hertz, then you will get this kind of waveform. And if you superimpose, just you see here, this is this peak and this peak, if they are added, you will get this kind of things, right? And if this peak and this peak they are added, you will get this kind of things, right? So these are nothing but superimposition of the waveforms, and resultant waveforms are this. This is the only fundamental component, and this is the desired component actually. What we desired from the power system, this is the desired component. That means we always try to maintain the 50 hertz component presence. If it is you are feeding power to the machine, we always desire only 50 hertz component must go in the machine. If you are feeding this kind of components in the machine, what will happen? Some losses may occur, some poor power factor problem, some reactive power injection may be there. So all these things are not desirable. Sometimes like VLDC machines and all, we desired such kind of components, right? But those machines are specifically designed for such kind of components. That's why you can inject But in the normal system, where suppose induction machine is running or some transformer is connected, that always needed 50 hertz component. Otherwise, there will be a lot of problems. And these are the sources of power quality problems. Unidentified and identified sources, there are two categories, and they are just equated from the harmonic pollution to air pollution. TV sets, personal computers, all these things, inverter based home appliances, such as adjustable speed heat pumps, adjustable speed motor drives, and they are creating the problems, harmonic pollutions in the system, right? And these are the bulk diode, thyristor, cycloconverters, arc furnaces. They are also creating harmonic pollution in the system. And this is the adverse effect of poor power quality on the distributed generation system. Power quality problems causes failure of capacitor banks. Actually, capacitor bank, you want to you have connected, or we have connected according to the 50 hertz. The reason is, if we are supplying multiple frequency component to the capacitor, its impedance will be continuously varying, and there may be some problems of the capacitor bank with the adjacent inductor in terms of EMI resonances and all. That's why the failure of capacitor bank is possible if you are supplying poor power quality to the capacitor bank. Increased losses in the distribution system and electric machines, noise, vibrations, all these are the resultant of the poor power quality. Negative sequence we were discussing quite earlier. Negative sequence currents in generators and motors, specifically rotor heating, derating of the cables, dielectric breakdown, all these things may happen due to poor power quality. Interference with communication system, yes, because if suppose your communication system is working at somewhat within the kilohertz is, and your suppose presence of 10th harmonic or presence of 11th harmonic is there, then or presence of 19th harmonic is there, then that signal is directly going into the zone of that means digital signal, right? Or you can say communication signal. Then it may interfere with that signal and will create some problems, small operations of the relay and breaker. False metering, interferences to the motor controller, digital controllers, and so on. All these are the common problems which are occurring in day-to-day power system due to poor power quality. Actually, if we are discussing something related to power quality, or if some researchers are working in this domain, they must have some knowledge about the standards. Basically, we always have to quote, if we are maintaining power quality at such level, we have to quote, yes, it is accurate or it is recommended by the some IEEE standards. Suppose if we are discussing about the harmonic control in electrical power system, this is governed by the IEEE standard 5191992. In case of you are writing the research paper, you have to mention these kind of references. In the reference list also, you have to keep one or two standard references, because you are comparing your result, you are whatever the findings you are writing in your conclusion, you write there, yes, this result is obtained as per this standard and acceptable, it is in acceptable limit. So these sentences you are using, that's why you must have the knowledge about some standards, and these standards must be included in your reference list, and you have to quote these standards either in introduction or in some abstract or in conclusion, right? Suppose directly in conclusion you are writing something without any comparison, without any comparative results, without any benchmarking system, comparison with benchmarking system, then there is no use of those kind of conclusion sentences, right? That's why for effective conclusion, for making it effective, for effective abstracts, you have to quote all these kind of references, and you must have this knowledge. So IEEE standards 1159/1995. This is the practice for monitoring electric power quality. This is another one region of working. So many peoples, I know few peoples from Punjab University is working only on the monitoring of the electrical power quality. That means they are not maintaining, they are just monitoring. They are measuring the sag, they are measuring the swell, they are predicting the amount of sag and swell. So these things are also very effective research area, monitoring electric power quality. right? And then IEEE standards 1100 1999 recommended practice for powering and grounding sensitive electronic equipments. So this is also one area which can be used for our research. Electric power distribution reliability indices. Suppose IEEE standard 1366. If somebody talk about, you immediately reliability must click in your mind. Suppose 519 IEEE standard. If somebody is talking with me about IEEE standard 519, if somebody is talking like I have compared my results with IEEE standard 519, then without saying harmonics, immediately this will come in my mind. Yes, you must have some harmonics indices, or you must have some results and you have compared with that standard, right? So only codes are, if you are working in this area, only codes are sufficient. These descriptions should come in your mind immediately, right? So this is the way of study, this is the way of learning, this is the way of research. Some other IEC codes are also available, and suppose particularly for compatibility levels for low frequency conducted disturbances and signaling in public supply systems. IEC standard 6100022 is available, and all these things are available in some standards, and we must have the knowledge. Basically, now we have discussed quite a lot what is power quality and what is the need to maintain good power quality. Now the question is how to maintain good power quality. Let me allow to take some water. Now, basic principle of the power quality. Basically, what we discussed till now, just I would like to summarize. We have discussed about the power quality in the distributed power generation system, in a standalone mode power generation system, what is the need, why we maintain the power quality. Now the third point is how to maintain the power quality. Suppose we also discussed about two power quality issues. One is related to voltage power quality issues, one is related to current power issues, and sometimes voltage current power quality issues may be available, may be there simultaneously. Suppose here, that's why we have taken three cases. One is related to current power quality issues, this one is related to voltage power quality issues, and this is related to current voltage power quality issues, right? Any question, any query? Don't be a passive listener. You can ask, you can make the interactive session. I would like to learn something from you people also. It is not like I am teaching, just I am interacting with you.
One request from my
Hello?
hello, sir. Am I audible?
Any question?
Yes, sir. Am I audible?
Are you enjoying the session?
Someone is
Sir,
speaking, sir. Please
am I
speak
audible?
loudly.
Am I audible, sir? Hello.
Yes, any query?
Am I audible, sir? Am I audible to you?
Yes, yes, yes. You are audible, sir. Please
Sir.
speak loudly.
Okay, sir.
Yeah.
Sir, if possible, try to conduct any sessions on simulation or experimental, because as every session is theoretical, I don't know how others are interacting, so that might be the problem.
Definitely, we will conduct. Your
Yes,
suggestion is
yes, sir.
fully solicited, and we will try
Yes,
to. Today, I will show the results. Tomorrow, I would like to. I would request my one PhD student is also connected here, and
yes.
I would request him to show some simulation results also. Right?
Okay, sir. Because we are keep on listening the theory classes in most of the sessions, but we are facing issues when we are doing simulation. So that is the reason I am asking.
Yes, yes, correct, correct. Even if you have any difficulty in the simulation, you can discuss here. We will give our suggestions.
Okay, sir. Sure. That
Suppose
so
if you are
when
working
you
in
are
this, if you are working in this area and if you are facing any problem, I will try to solve your problem immediately. Just you share with us. You can present from your side your simulation, and we will make if some corrections are needed or if your simulation is not working. We will give our suggestions. You just incorporate. Simulation may be working. Though
Sure.
I will show you some modeling diagrams. I will show some simulates. Actually, my MATLAB version is quite old, and there is problem for live. That means this session and MATLAB both cannot work together. Actually, the MATLAB, if I want to make it present, I have to go and change my date and time setting. And when I am going to change the date and time setting, internet problem will be there, and this session will not be. But still, I will try because I have to take two sessions. I will try my next session tomorrow in the afternoon. I will try my level best to show some simulation also. Your
Okay, sir.
suggestion is quite solicited. Thank you very much for your suggestion.
Thank you, sir.
Any other participant?
Hello, sir. This is Sundaram Pandya.
Yes, बोलिए पंड्या साहब.
Yes, sir. What is the difference between characteristics harmonics and non-characteristics harmonics? How we bifurcate these two harmonics?
Characteristic harmonics and
Non-characteristics harmonics.
actually, I understand characteristic harmonic means these are the harmonics which are in integral form, right? Suppose
Yes.
fundamental along with fundamental, you are having third component, fifth component, seventh, ninth, and suppose
Yeah.
11th. All these integral components are known as characteristics harmonics. They can be characterized by their nature, right? But sometimes we are facing the problem of intercomponental harmonics, like 2.5th, 2.25th. Like yesterday, Joshi sir was telling about 20 hertz component, right? Fundamental component 50 hertz and 20 hertz. If they are mixing, you are not getting the exact multiple, right?
Multiple of
Suppose you are
fundamental.
not getting the integral component of the frequency. So these
Yes,
are the, yes, hello.
yes, sir. Yes, sir. Continue, sir.
Yes. So these are the, that means we can say uncharacterized component of the frequency, right? Generally, it is very difficult to trap them also, very difficult to design the filter for them also. That's why their characteristic is not matching with the design exactly, right? Suppose if
So,
you
sir,
want to filter,
we can say like that is the integral of fundamental harmonic. That is known as the
it,
characteristics harmonic.
yes, suppose fundamental is 50 hertz. If you are getting 150 hertz component,
Yes, the third
250 hertz
harmonic.
component, 750 hertz component, these are characterized harmonics. And we know the characteristic of third component, fifth component, seventh component, all those, right? We can
Yes, sir.
design the filter to remove them. But sometimes what happens, that means interharmonic components are available in the supply system, right? And they may be coming due to that means what we can say, design problem of the generator also. If
Yes,
generator
sir.
is not uniformly, if air gap is not uniformly designed, which
Yes, sir.
kind of harmonics it is going to create, we are not knowing it,
Yes, sir.
right? These are the
Okay, sir.
problems.
Thank you, sir. That is a very informative answer from your side, sir.
Thank you, Pandya Sahab, for making this session interactive. I am
Thank you, sir.
always interested. My personal interest is to discuss maximum. Okay, lecturing is okay. I am not giving anything extraordinary. What I understand, just we have done something and we are sharing with you people, right? You all are experts in your area, and you can also, we can learn something from the participants if they are ready to share, right?
Yes, sir. Very, very right, sir. Very true.
Now we are working, we are basically, anybody else? If any question you have, please ask without any hesitation. Okay, now we are basically discussing here the basic principle of the power quality. So I have shown here three type of systems where we are maintaining the power quality. This is the system where we are maintaining the current related power quality. This is the second system where we are maintaining the voltage related power quality problems, and this is the system where we are maintaining current and voltage related power quality problems. Now, first of all, I am discussing this one, and in this entire session, our focus is to maintain only current related power quality problems, because we assume that our supply system is perfect and generating purely sinusoidal waveform. Now, suppose basically there are three components in the good power quality system. If we see here the T component, that is the vertical line of this T junction, if you disconnect for a certain time, for a time being, suppose if you make it disconnect, then only series path will be available from supply to load. And here, if it is a non-linear load means RL circuit connected from the diode, or some rectifier circuit connected from the motor, DC motor, or some adjustable thyristor based circuits, adjustable speed drives, variable frequency drives. If those are the loads connected from here, they are definitely going to create some power quality across the system. And here just I am taking very simple load, non-linear load, diode and RL circuit, right? RL circuit is connected from the diode output, and diode is connected from this place. It is only single line diagram. That doesn't mean it is a single phase system. Single line diagram means all the three lines are replaced with a single line, right? Now, if you see the load current nature, this is the quasi square wave, you can say, or you can say this is the square wave, not quasi square, right? This is the square wave load current, and if this vertical line is disconnected for a time being, the same load current will be demanded from the AC supply, because being an electrical engineer, we know if load and supply both are in series, whatever the load current, that will be equals to the supply current. Now the thing is, if you do the Fourier analysis of this load current, it is not the 50 hertz component. There are 50 hertz component along with multiple frequency components. Right, this load current is not the sinusoidal current, and if we do Fourier analysis, we will get fundamental frequency component, third, fifth, all those components will be coming. And what, due to non-linearity of the load, these components are demanded from the supply system. That means you are not demanding only fundamental component from the supply, you are keeping demand of multiple frequency component from the supply system, right? And due to presence of multiple frequency components, the electromagnetic torque, if it is a generator, electromagnetic torque will be disturbed. If it is a AC supply, means ultimately supply current is disturbed, right? Voltage, though voltage will be sinusoidal, but load current will be in this nature. Definitely it is going to have some power factor, poor power factor, because the fundamental load angle will be different from the original sine component of the load current, and power factor problem will be there. More reactive power demand is kept on the supply, right? And some other heating related problems may occur. Hello, please unmute. Please mute yourself. If you have any question, then only unmute, otherwise be muted. Okay, now what to do if this kind of problem is created from the load? Then we will have some this component. This is known as shunt active filter or DStatCom, right? This is power electronics based device. That's why I was talking power electronics involved in the load, it is creating problem. Power electronics involved in the filter, it is providing the solution, right? All the power quality related problem related to current, it is eliminated from this filter, right? Only thing is we are generating one modulating signal for the this active power filter. We are generating one modulating signal for operating the switches, and according to the reference supply means sinusoidal. right? Our supply current must be sinusoidal. Whatever the desired quantity, that desired we are making as a reference. So we are making sinusoidal reference for the shunt active filter, and sinusoidal reference is compared with the actual supply current, and we are creating one error modulating signal. Whatever the error is there in between the actual and sinusoidal reference, accordingly you are operating the switches by some carrier signal, and basically all the components which are demanded apart from the fundamental, you are supplying from this side, right? That means if suppose here 1 3 5, 1 means fundamental, 3 means third harmonic, 5 means fifth harmonic. If 1 plus 3 plus 5 is supplied from this generator, and after connection of this active filter, third and fifth will be supplying from here. The generator is relieved from the third component and fifth component supply. Generator will supply only the fundamental component to the load, right? And this current is known as compensating current, as it is known as compensator. Basically it is working as a current compensator. The current compensator is, suppose for this case, current compensator is supplying this kind of current, and if you add these two components, IC plus IL, you will get the sinusoidal supply. You will get the sinusoidal supply, right? So this is the thing you have to verify the KCL as well. That means supply current must be equals to the IL plus IC, right? And KCL must be verified at this end. Whenever you are showing any result, you have to show the verification of the KCL as well. So this is the current related power quality and how to solve the current power quality problem. And this is the voltage related power quality system. Voltage related power quality, what we are assuming here, in this case we are assuming our power system is not having any kind of voltage fluctuation, but in this voltage fluctuation is there, right, due to any reason, but your voltage is fluctuating, and sometimes sag is coming, swell is coming, sometimes its time period is not uniform. So these things are involved over here, but what our desired thing is we must have constant voltage across the loading conditions. That means constant and sinusoidal voltage across the loading condition. So here the desired quantity is sinusoidal voltage. In this previous case, the desired quantity was sinusoidal current from the supply side. Here desired quantity is sinusoidal voltage at the load side, right? That's why what we are doing here, we are injecting one compensating voltage in the series of this path, because voltage will be connected in series. This Vs plus Vc equals to VL. This will be the verification of KVL in this case. Vs plus Vc equals to VL. Suppose if voltage sag is there in this, suppose 176, then from the compensator side, and your requirement is suppose 220 volt, then from the compensator side you have to inject under root 220 square minus 176 square, right? Accordingly you will decide the DC link voltage. Accordingly your transformer will convert from primary to secondary, and the secondary voltage must be in addition, phasor addition of this Vs and Vc, that must be equals to the desired sinusoidal in magnitude and in phase. So by this way, here series active filter is there. This is known as series active filter. What it is doing, it is creating sinusoidal voltage reference. Series active filter is working on the base of sinusoidal voltage reference, right? Ultimately these switches are operated with the voltage reference. Here the switches are operated with the current reference. So this is the only difference in current quality related problem and voltage quality related problem. In this one, what we are doing, we are adding back to back. We have taken current related power quality problems in the right hand side, voltage related power quality problems in the left hand side, right? And common DC link is there. Important thing is design of DC link also. We will see in the next session how to design the DC link and all. And here current and voltage, they were addressed separately, but in this UPQC, this is known as UPQC actually, right? And UPQC, there are two components, shunt active filter and series active filter. They are connected back to back through the common DC link, and we are designing their controller separately, because this will be based on current source reference and this will be based on voltage reference, right? So we are making two references. Hello, may please mute yourself. Now the power quality research perspective, how to proceed in the direction of research. If somebody wants to pursue, then there are scopes in the system configuration. You can design your own system. You can change the system configuration, like you can take suppose multi-level inverters in this place. You can take 2-level, 3-level, 5-level, 7-level, any level converter you can take. You can just you operate the switches according to the desired reference and you will get the desired result. Similarly, suppose you can change the configuration by suppose isolated topology, non-isolated topology. I think so that will come in the later slides, but my point is very much clear here. I think so you can have the research scope over here, or you can have the research scope over the generation of reference, right? That is the control part. So basically there are two things, because you will not change the AC mains and load. They are going to remain same, but you can change here, or you can change the operating procedure of the switch. That is the things coming from the control side. So this is the system configuration. This is one issue. Control algorithms is another dimension of research. You can take so many type of variety of control algorithms for generation of voltage and current reference. They may be based on Laplace, Webled, Parks class, and they may be based on some state space model such as Riccati and Fokker-Planck equations. Based on adaptive theory, basically, when I was doing my PhD, I was very much focused on this theory. Adaptive theories such as LMS and its variants. Then model predictive is very, that means research, very nice research domain. People can work on the model predictive as well. And this is based on optimization, such as I know Professor Sundaram Pandya has worked a lot in this optimization domain, such as particle sum, Jaya, CW, TLVO, all this. Professor, hello. Nikunj sir, please mute them. Please mute yourself. Based on classical theory and PLLS, all these are the control algorithms. There is variety of neurophagy control, such as back propagation, etc. I will discuss here. All these are the different controls, and this is the simple architecture of the general distributed generation: wind turbine, battery, solar fuel cells. With the help of power electronics interface and switches, you can connect at them with the common point of common coupling, and loads may be connected from this. And our target is to maintain the power quality across the loads, right? Sometimes they may be connected from the main gate through this main switch. Sometimes they may be working without connecting the main grid. All these are the general architecture of the microgrid. This is very simple configuration of the microgrid, where two sources, solar PV arrays and this wind turbine generators, they are taken for the power generation in parallel, and SCIG means squirrel cage induction generator is directly connected from the load. This is the PCC, actually, point of common coupling, where load is connected, and this is the excitation capacitor bank needed for the generator. And this is the basically 4-leg converter, right? Because we are addressing here 3-phase 4-wire system. So this is the 4-leg converter. 4-leg is addressing the neutral current compensation. These 3 legs are addressing the phases of A, B, C, right? And this is the battery energy storage system using bidirectional converter, right? And this is the solar power radiation. Solar power is connected at the DC link. You can see here the DC link. So these two sources, this is one possible configuration. You can make your own configuration. The important thing is that configuration should work. Results must be convincing. There is nothing like this is the standard configuration, right? You can make your own configuration. You can change the topology of the converter. You can change the topology of this converter. Whatever you like, there are innumerable literatures available on these configurations, right? You can do anything in this segment of research, but the only thing is important is not configuration, important is convincing results. Your results must be convincing, right? These directional MPPT control algorithms are used to operate the bidirectional converters, right? And battery bank charging, discharging, and this is the control algorithm where you are creating the signals. What I was talking about, you have to generate the current reference, right? Sinusoidal current reference from where it is getting, that will be generated from the control algorithm over here. And this is another possible combination. भाई कौन है चालू करके रखता है? Who is? Why people are continuously? Please switch off your camera. Now this is another possible combination, or you can say topology, where you can run the diesel engine based SCIG and wind turbine based permanent magnet BLDC generator, and with the help of this diode rectifier, the AC power is converted into the DC, and this is the, you can say, bidirectional boost converter. You are boosting the voltage over here across the DC link. That means DC link is common basically, and these three phase loads are connected from the generator, and ultimately converter part we are just providing the active power support from here, right? That's why wind turbine and this diesel engine based SCIG, they are connected at the common DC link, and ultimately there are two things happening here. One is active filtering, that is maintaining, that is supplying the desired level of harmonics of the load from this place, and second thing is maintaining active power support from this end. That's why this power is converted into DC, and DC link is charged now, and whenever required you can connect one battery also, because it is a standalone system. You can keep one battery also, even if this battery setup is there. This is the modeling of the actually battery RB, CB, VB and RS. These are the component wise they are kept here. In standalone mode, battery is one integral part of the system. Right? With the help of MPPT control algorithm, you can create the duty cycle for operating this switch. This is the boost converter, and you are boosting the voltage up to the DC link voltage, and ultimately through this path you are providing the active and reactive power support. Similarly, from this path you are providing active reactive power support with proper power quality. Now this is another configuration where we have connected the PMSG wind turbine based system through this rectifier using again the boost converter, and basically these things you can see here. This is the DC link. First of all, you can disconnect these two lines and see the system. Load is connected, grid is connected, and ultimately solar and wind turbine, they are connected at the common DC link, right? That means directly PMSG is not connected from the load. That is giving real power and reactive power over here, and with the help of this converter we are maintaining the supply and grid. This is basically grid connected system also. And power circuit of only wind energy conversion configurations you can see here. These are the generators connected from the load, and this is the PCC single phase, and there are 4 switches only required because it is a single phase system. Battery energy system, then this is the another auxiliary load for maintaining the frequency because it is a standalone system. If sometimes battery is overcharged, then you have to dump the energy in, only way is to dump the energy in the dump register. So this is another configuration. There are some other configurations you can work with. These are based on DC link, right? And these are based on 6 switch configuration. These are based on 4 switch configurations. The only challenge over here to maintain the equal voltages, but the simplicity is we have to control only 4 switches. And some is based on isolated topology, non-isolated. Suppose this is based on isolated topology. The advantage of the isolated topology is less DC link voltage is required to maintain, right, across the capacitor. Suppose to handle the 800 volt DC link and to handle the 200 volt DC link. So 200 volt DC link handling is easy as compared to 800 volt DC link, because we know, I have worked on the hardware system, it is very difficult to maintain at the higher side, right? That's why sometimes these kind of topologies are very much important and useful, right? These are again isolated topology with 4 switch configuration. You can see here the only change is here 6 switches and here only 4 switches, right? We have to generate only 4 signals. And these are the some neutral current compensation based topologies. Here star delta transformer is used. Sometimes zigzag transformers are also useful for maintaining the, because actually this is the combination of active and passive both, right? Not only active compensation, you are doing with passive compensation as well. And here this is the system where load is based on 3-phase 4-wire, but loads are single phase loads, right? Initially we have taken the 3-phase loads, like all the 3 lines are connected from the 3-phase diode circuits, but in this case single phase diodes are taken. So these are the possibilities of the configurations you can work with. And if somebody is planning to do some research in this domain, you can do. And these are the research scopes. I am skipping it. Control algorithms. And then now actually I am coming on our topic, that is the intelligent control algorithms and why it is required, right? Given the smaller size, lower inertia, involvement of power electronic interface DCs, and the limiting smoothing of the demand spikes, microgrid applications or distributed applications may face significant control stability power quality. Actually inertia is very less, very vulnerable. Actually if you are changing the load, and if induction generator is connected directly from the load, voltage and frequency immediately starts fluctuating because very less inertia of the generator, right? It is not interconnected power system where inertia is quite high, it cannot be changed. But in the you can say less inertial system, these things are very much vulnerable. That's why some sophisticated controls are required which will provide directly and fast control to the dynamic conditions. And the device level control, if we are implementing this, it is known as primary control in local area, and supervisory control, then it is known as secondary control, and grid interactive control is known as tertiary control. But basically we are working over here only device level control, primary control. We are not using any kind of area control system or grid interactive control. In this work only device level control, that means we are controlling only inverter. Right. So these things are given. Just I am discussing some basic control that is known as classical control theory. And I hope so people who are working in this domain or who have worked in this domain, they will be able to understand what I want to tell. Basically, if we are talking about the device level control or primary control, then means we are generating some reference current. And if somebody is working on the series active filter, they may be generating some reference voltage, right, for the device. That's why I'm talking about inverter control in both cases, either working on voltage reference or current reference. Basically we are doing the primary control, right? Now how control mechanism works, actually how we are creating reference currents for the inverter. So you can see here, this is the basic reference theory, reference frame theory, and it is known as basically classical. Continuous disturb I am getting.
હા હા કઈ રાહ જો એક બે દિવસ જો આવી જતું હોય તો વાંધો નહીં હા ને હા
Anthony Robinson. People are not listening. Now see, implementation of SRF theory based control algorithm for the reference current estimation, how it works, just I would like to throw some light over it. Basically, the problem is created from the load side. That's why we are sensing the load current, right? And all these three load currents are converted. This is the reference frame theory, or it is classical control basically, where three-phase PLLs are used and ABC to DQ conversions are used. All these conversions, and when PLLs are used, basically these controls are coming under the classical control category, right? So ILA, ILB, ILC, they are sensed through some sensors, that means current sensors, and they are converted into ABC. And what we want to know, we want to know the real and reactive power demand of the load actually. That's why we have converted into two components, two decoupled components, ILD and ILQ. By using the low pass filtering, almost 10 to 20 radian per second cutoff frequency used here, so that these components, if there is any fluctuations, interharmonic components are present, they must be filtered out, and you will get the pure active DC component from the AC load, and here it is the reactive purely DC component. That means you will get the straight line components over here and here. Now I am going in these two controls, right? VDC reference, because we have to maintain the DC link voltage anyhow, otherwise our inverter operation will not be effective. That's why we have to set the DC reference. Now the question is, what should be the value of the DC reference? If somebody is working in this area, they may be knowing DC side is almost 1.6 times more than the peak voltage of the AC side, right? That's why for 230 volt system, you have to maintain over here 400 volt DC reference. If you are suppose taking for 240 AC side system, I am talking about this system. Suppose here it is 240 volt at PCC, because PCC is nothing but working at AC. And if it is 240 volt system, then DC side must be 400 volt system, right? So we are maintaining the reference voltage so that your capacitor can be maintained at the fixed DC level. Here DC voltage is the reference DC voltage is 400 volt. Actual DC is sensed from the DC voltage sensor. Again, LPF of 10 to 20 radian per second cutoff voltage, cutoff frequency is used, and they are compared to each other, right? This is the reference and this is the actual, and then there may be some error, and that error is processed through the PI controller. We are using here normal PI controller. Somebody may use some advanced PI controllers like fractional PI controller, fractional order PI controllers, or some optimized PI, optimized gain PI controllers. In our research group, people have started using optimized PI controller, where we can tune the gains using some optimization algorithm also. So there is another scope of the research in this control algorithm. So there are that means there are much scope in the control side. The reason is, if you are working on the hardware, you cannot change the hardware within day and night, because hardware development requires a lot of efforts, right? But suppose you have developed one hardware, you can implement so many control algorithm on the same hardware, and you can publish your paper, you can finish your PhD. So DC link, reference and actual, they are compared, and error is processed through the PI controller, and then PI controller is creating one active component, current component, that is equal to the loss component in the inverter, right? That means basically what we are demanding, how we are generating the active component for the generator, because generator will supply the real power for the inverter component also.
I have done it, sir. You carry on.
ये चालू करे तो उसको रिमूव ही कर देने का इस बार.
Okay, sir.
ठीक है ना? If somebody is not listening us,
Okay, sir.
they have no right to be here.
Okay.
I am requesting so many times, please mute yourself unless and until you are not having any question. If you have question, you can ask. ये तो मेरा ही session है and you are discussing like this. If somebody is from external, it will be a problem. Now PI controller output will come to the loss component in the inverter, and this will be the active component from the load side. Similarly, we will have another component, that is reactive component from the load side. Now you can see for the generating the source reference, we are adding active and active, right? Plus is very important sign. It is not like anybody can put here plus minus, minus plus, minus minus. It is not like that. You have to keep here plus plus. The reason is generator is supposed to supply entire active component from supply side. That's why it is kept plus plus. And here why we are keeping plus minus 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 and plus. The reason is we are taking another error controller, that is the amplitude calculation and amplitude reference. At the same time, we are maintaining the frequency, or we are maintaining the DC link constant. At the same time, we are maintaining the voltage at the PCC constant, right? Voltage of the supply line should not be going down. That means there should not be any sag or swell over the supply system. That's why we are comparing another voltage controller. We are keeping here PI controller for the voltage control loop. There are two control loops. One is DC link control loop and another is voltage control loop. So how to calculate the voltage error? VSA, VSB, VSC can be sensed from the supply system through voltage sensors. The amplitude will be calculated. VS equals to 2 by 3. There is formula in my papers as well. Vs equals to under root 2 by 3. VSA square plus VSB square plus VSC square. And the voltage magnitude will be calculated over here, and you will set the voltage reference as per the calculation. Suppose you are working on 230 volt system, then the voltage reference will be 195. Now how it is calculated? 230 divided by root 3 into root 2, right? By this way, this will be the reference. 195 actual voltage you will have. Error can be calculated by comparing these two components, and then error is processed through PI controller. Some Kp and Ki values are required to process this error, and again one reactive component will be created. And this reactive, this is the source current reactive, right? This is the reference for source current. So source current should supply less reactive component. That's why it is taken as plus and minus. Maximum power will be supplied by the compensator. Reactive power will be supplied by the compensator. That's why only the difference of compensator reactive power and load reactive power. Suppose compensator, if compensator is able to supply entire reactive power demand of the load, this IQ component will be 0, right? But suppose if you have not designed it properly, that's why this margin will be there, and the difference of the reactive power from load and compensator, that will be supplied by the generator. Then ID star and IQ star, and you will convert this into DQ to ABC ultimately. Then finally you will get ISA star, ISB star, IST star. These are the star quantities, or you can say the reference source current, and these are the actual source current. They will be compared and fed to the PWM controller for generating the VSC pulses, right? Finally, you will get the gate pulses for the switches, and entire operation will be of the system will be controlled. So this is one classical control theory where three-phase PLL is used. Now the limitation of three-phase PLL is under the voltage distortion conditions. These three-phase PLLs may not work actually. They will not give you the accurate estimation of cosine theta and sine theta. These components may also be disturbed in nature. That's why classical controls are somewhat slower controls. They are not much effective under random dynamic conditions. If suppose changes are very small, or you can say for a time being, then these controls may be very effective and very simple in nature to implement. But if randomness is quite frequent, then these controls are almost ineffective. Nowadays, these controls are considered as obsolete control. That's why people are started working on intelligent adaptive controllers, and they are used as a primary control in microgrid or distributed generation. Now the thing is, what is the adaptive control and what is the working principle? Time permits us?
Yes, sir. 10 to 15 minutes.
Okay. Otherwise, I can take next from adaptive Adeline control algorithm in the next session. I can, because if I will start, it will take much time.
Uh, then,
I will continue in the next session
yes, sir.
from the adaptive control.
Yes, sir.
If anybody have any question, they can ask, please.
Sir, I have a few questions, sir. Am I
Yes,
audible?
yes. Yeah,
So
yeah, you are audible.
can you please go to the slide number 20, around 20,
Just
23,
a minute.
something?
This one?
Yes, sir. Yes, yes.
Yeah.
So before this, I think before 2 to 3 slides, you have given the shunt active power filter configuration circuit, and now here you added PV and wind
Yes,
also.
yes.
And in the next slide, you have added
That
both
means
PV and wind.
this
Yes, sir.
one, this one.
Yes, sir. Yes, sir. Yes.
Yes, this is
So,
just working principle actually. This is not the
yes.
exact configuration. And in that slide, we have shown some configurations. Yes.
Yes, yes, sir. So my doubt is, in all the three configurations, you are using the common thing is VSC, voltage source converter.
Yes.
Common thing is. So if that is the case, what are the changes we have to consider when we move from without any source towards DC link to this PV and also PV plus wind? So what are the changes took place that we have to consider and designing
Actually,
or controlling part?
yes, 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 yes. I got your question. Now the thing is, when you are changing your configuration, right? Suppose I am showing you 2, 3 configurations. This configuration, and this configuration. Right? Just you go through the changes. Changes may be in the topology, changes may be in the control implementation, changes may be according to the simplicity of the topology, right? The same topology, but you are making it simple. Suppose sometimes you are using 6 switches, sometimes you are using 4 switches, though VSC is there. Sometimes VSC you can use, but it may
Yes,
be
yes.
3 level.
Sorry to interrupt. So, so my basic doubt is, sir, suppose three-phase grid is there, and a non-linear load you're considering, and assume there is a six switches inverter. Then without PV, with PV, and with both PV and wind. So, if we take these are the three cases, then what are the changes we have to consider? That is my basic doubts.
What are the changes in what? Actually, changes in what?
Changes means with regard to selection of ratings and with regard to control part. What are the changes
Okay.
will come in control part, control algorithm part
Yes,
in
yes,
generating signals,
yes,
reference
yes.
signals.
Yeah. Actually, see, when you are, suppose for example, I am discussing this in now I got your question clearly, and suppose this PV is missing. For example, in one case I am not using PV, right? Then what we are using for a supply source, we are using only generator. Generator is connected from the nonlinear load, and through this VSC and this battery setup we are maintaining the power backup, and through this VSC we are maintaining the power quality, right? Then what we will do for the current reference generation, we will take only the current of load, current of supply. Are you getting my point?
Yes,
In
yes,
one case, what we will take the current of load and current of supply. These will be the sense current, only 6 current we are going to sense. But suppose when we are using this PV as well, that means for the similar loading condition, suppose this load is 5 kilowatt, right? Then in the first case, the generator must have some 5 kilowatt capacity, Now, suppose for the similar 5 kilowatt load, you are using additional supply system, that is PV array. Then what you are doing, you are maintaining some real power from this side also. In the previous case, there was no real power support from this side. But now in this case, real power support is there. That's why when you are considering the reference source current, you will take the difference of the this load current minus the PV current for the generation reference, right? In the previous case, you are not taking any difference for the generation source current. You are taking only load currents. But now for generation, if you are calculating the reference current for the generator, you will take the load current minus these three currents, or you can say supply current, supply from the PV. That's why this will be the change during control, right? When you are doing the control design, you have to additionally consider the component of the PV, real power component of the PV. And when we are calculating the real power, because we are maintaining reactive power from this side, capacitor DC link is there. It will be able to supply the reactive power supply, reactive power support to the load. But the only thing is, when we are creating a reference current for supplying the real power from the generator, we have to take subtraction of this current from the load current. Are you getting my point?
Yes, sir. This point is clear, sir. Coming to rating side, selection of inverter. So what change we have to consider, sir? So
Actually, as far as yes, actually in the next session I will discuss the design of the inverter, how to design the switches. All these things will come in the next slide. Almost after I am showing you that slide, but I will discuss tomorrow. Things are coming here. Suppose the design of interfacing inductor, design of the generator, design turbine design. These things I will discuss. Calculation of VSC current for current ripple, and selection of the battery energy storage system. All these things we will discuss. But because today you have asked this question, I am giving you a very brief answer about it. Otherwise, I will discuss in detail tomorrow. But the thing is, when we are maintaining the supply side, see, when you are simulating any kind of system having generator, load, PV, suppose such kind of system, this is 5 kilowatt load, this is 5 kilowatt generator, it may be 2 kilowatt your PV array, then total supply source becomes 7 kilowatt, right? While total load is only 5 kilowatt. But the thing is, this 7 kilowatt is the installed capacity. That doesn't guarantee every time it is going to generate 7 kilowatt, right? But your capacity is 7 kilowatt. The possibility for a few hours that may be running at optimal operating conditions, and it is creating 7 kilowatt. Suppose for a while 2 hours 7 kilowatt is created. Then whatever that surplus supply is available, that is going to be stored in the base unit. That's why I told in a standalone mode operation, when mismatch will always be there, the possibility we cannot deny. The mismatch possibility between the load and generator will always be there, and the mismatch of the real power will be stored in this battery. That's why here bidirectional converter is also used. Sometimes battery will be in charging mode, sometimes it will be in discharging mode. Another possibility, when both are you can say ineffective due to some reason, suppose this is not working, or 5 kilowatt install capacity is there but it is generating 1.5 kilowatt, and suppose 2 kilowatt install capacity, it is generating 0.5 kilowatt, then you must have this backup, and it is proper calculation of this backup. I will discuss tomorrow for designing the components of the configuration, and in that backup you will see time hour consideration is there. Suppose you want to design 6-hour backup, 4-hour backup, according to the rating conditions, rating of the load, rating of the generator, rating of the PV, accordingly the rating of the BES is also designed, and it will provide certain hour backup to entire system if both sources are missing. Suppose missing means they are physically there but their capacity is unutilized. So by this way you can design it, And basically you see, if you are taking any system design, you have to consider the load demand in mind. Suppose it is 5 kilowatt, randomly you cannot design for 20 kilowatt and 50 kilowatt. Suppose it is 5 kilowatt, you can take it 5 kilowatt, 5 kilowatt, or 5 kilowatt, 3 kilowatt, 3 kilowatt, 5 kilowatt, like this only, right? And first of all, you are taking the power rating of the generator and then other components, that is the matter of machine design. Basic designs are, we are generating voltages, we know at which voltage we are going to generate, as which level voltage we are going to generate, what should be the maximum power limit of this generator, what should be the frequency of the generator. So all these are the design parameters, and these things are given in MATLAB as well. Some pre-models are available in the MATLAB, you can take and you can simulate it. Similarly here, suppose you want to generate 3 kilowatt, 4 kilowatt, 5 kilowatt, accordingly you have to select the number of strings, and then you have to see the string voltages are how much, VSOs in open circuit voltage, open circuit current, and then by using the MPPT algorithm, you have to see at which potential level you are coming, either it is matching with the DC level or not. So accordingly, you can change the design of the PV. There is no specific method how to basically how to select. It will be some trial and error, and it will be based on your experience how to put the parameters for the source part, right? Load, similarly load part, somebody is taking random values of load inductance and load resistance, but you must know, we must know, in fact we must know how to create the distortion in the current, how to select the value of inductor so that 30% distortion may be created, 40% distortion may be created. Sometimes students are asking, sir, distortion is only 10% and we are maintaining 5% as per IEEE standard. That is no use. At least you have to create 40% distortion in the load current. So we must know how to create 40% distortion with the same 10 ampere current, right? So that is dependent on the value of inductor. Similarly, these inductor ripple filters must be properly designed. If you are putting random values of these filters, it is not going to work. So all these things, filtering, ripple filter over here, this is the ripple filter actually, and this is the filter of high pass band, high band pass filter, right? So these filters are having some proper design, and switching ratings, switch ratings, suppose IGBTs are used for this much DC link voltage, what should be the current rating of these switches. So all these things are having some proper calculation and design procedures. We will discuss in the next session, but because you have asked the question, that's why I given this answer. I hope so
Sir?
it is clear to you.
Yeah, yes, sir. It is almost clear. Only the request is, sir, anyhow, you are going to explain in the next session. Please try to consider the simulation of this system also, sir, so that we can understand this
Sure,
complete
sure,
idea. We can get an idea at least.
sure, sure, definitely.
Hello?
Because understanding the system on paper is looking easy, but when we are trying to simulate, or we may face some problems. So that is the reason I'm asking.
Yes, yes, thank you.
Hello?
Any other
Thank you, sir.
query?
Thank you for your explanation.
Thank you. Any other query?
Sir, the inductive filters we are using after the VSI, so sir, the main role is for reducing the switching harmonics, or does it have any role in reactive power compensation also?
Inductor is not playing any role for reactive power compensation basically. That is used for only shaping the current ripple as required by the load. According to the switching frequency, the value of inductor will be set.
Okay, sir. Thank you, sir.
Any other query? I hope so. You have enjoyed the session, and you have asked somebody. I have asked nice questions as well, and now I would like to wind up the session. Next session I will start from the implementation of adaptive control algorithms, and Sombir is here now. Sombir, Sombir, Sombir Kundu.
Yes, sir. Right now in a list.
यस सर.
हाँ, कल थोड़ा सा सिमुलेशन दिखा देना भाई.
हाँ जी सर, श्योर.
ठीक है ना, 10-15 मिनट, only 15 minutes. The reason is we cannot extend the session, but and simulation,
Sure, sir.
simulation, live simulation is not planned actually in session. Just I will show the results,
Okay, sir.
but how we are getting the results, you show them simulation, right?
Okay sir, sure sir.
थोड़ा जो बेसिक सिमुलेशन किया है, जो पब्लिकेशन हो चुका है, अनपब्लिश सिमुलेशन you will
Yes,
not
sir.
show. Simulation
Yes,
which
sir, yes, sir.
you have already published in the conferences, just you
Yes,
show
sir, yes.
that to the participants so that some are interested, and we should not deny them. We should respect their interest. Okay.
Yes sir, yes, sure sir.
Tomorrow I will give you 15 minutes to you. Just be ready with your MATLAB simulation for any single file. You show them. Okay.
Okay sir.
तो all participants please attend the maximum tomorrow my session. I will show you some simulation results as well as live simulations. My PhD student Sombir Kundu is also attending this seminar, and he will show you how to simulate the various circuits. Basically, he is working on the hybrid system, solar and wind energy based system. So he will show some his work which is already published, though there are so many configurations and topology control algorithms that is under review. We cannot show everything, but whatever the permission is given to us by the publishers, we can show them. Okay. So now have a nice lunch, and then we will meet again sharp at 1:30. The professor is very renowned person in the power system domain. Please connect at time before 1:30. I am again and again requesting, please connect before 1:30. Thank you very much for patient listening, and thank you Professor Nikunj for supporting me for this seminar, and for giving your valuable time to us. Thank you very much all. Thank you.
Thank you, sir.
नेक्स्ट सेशन कब
Thank
से
you
है,
sir.
Okay, sir. Okay, sir. Thank you so much,
Next
sir.
session 1:30.
1:30.
Next session 1:30. There will not be any change in the schedule. Professor Asuni Kumar will connect, will join, and he will take the session.
ओके सर, थैंक यू सर.